In this video, let us learn to draw VI characteristics graph of a PN junction diode. This table represents the readings taken when the diode is in forward bias. The first column represents forward bias voltage VF, which is usually increased in steps of 0.1. And the next column we have forward bias current, which is recorded against the forward bias voltage. So we have forward bias current IF, which is measured in milliampere. So for 0.1, the forward bias current IF is 0, for 0.2 0, and we have recorded till 0.7 where we have obtained forward bias current IF as 15. The next table represents the readings taken when the diode is in reverse bias. The first column represents reverse bias voltage VR, which is generally increased in steps of 1 volts, and we have increased the reverse bias voltage from 1 volt to 5 volt in steps of 1, and we have corresponding reverse bias current IR, which was measured in microamperes. For 1 volt it's 5, for 2 volts it's 5 microampere, and for 5 volt it is around 200 microampere. Now let us draw the VI characteristics for the diode when it is in forward bias as well as in the reverse bias. So both this characteristics curve has to be drawn in the same graph. Let us take a graph sheet like this and divide this graph sheet into equal quadrants. Like this, you could see I have divided the graph into equal quadrants. We need both positive and negative values. This side we have plus x, this side we have minus x, and here y, it's minus y with origin at the center. First let us do forward characteristics. For drawing the forward characteristics, let us take the positive values of x and y, that is the first quadrant. So forward bias voltage VF is taken along x-axis, and forward bias current IF is taken along y-axis. Whenever we write the parameters taken along x-axis and y-axis, we have to write it along with the unit. So forward bias voltage VF in volts, forward bias current IF in milliamperes. Next we need to take appropriate scale for forward biasing. On the x-axis we have taken 1 centimeter to be 0.1 volt. Since we have increased the forward bias voltage in terms of 0.1, we have chosen 1 centimeter is 0.1 volt, and the appropriate scale along y-axis is 1 centimeter is equal to 2 milliamperes. So in the next step we have plotted the values. So you can see along x-axis we have plotted 0.1, 0.2, 0.3, 0.4, and along the y-axis it is 2, 4, 6, 8, 10, 12. It goes on like this. Okay, so these are the readings for which we are going to plot the forward characteristics. For 0.1 it is 0. You could see in the graph it is plotting against 0.1 we have plotted at 0, and for 0.2 it is 0, 0.3 0, 0.40. At 0.5 you could see a little current of 1 microamperes, it is plotted, and for 0.6 it is 4 milliampere, it is plotted there, and for 0.7 it is 15. So all the readings are plotted here. In the next step, let us join all these points. When you join, you will get a curve like this, you will get a graph like this. So this curve represents the forward characteristics of a PN junction diode. Apart from drawing this forward characteristics, we need to know the knee voltage as well as the forward resistance of the junction diode. Knee voltage is nothing but it is the voltage at which the diode starts conducting. So, as per our readings, you could see at a 0.6 volt, the diode starts conducting heavily. So, at 0.6, we could see the forward bias current as 4 volt. After that, the diode will start conducting. So, we can say this 0.6 as the knee voltage. So, the knee voltage is equal to 0.6 volt. Next, we need to find out the forward resistance of the diode. For that, we need to draw a slope. Always take a slope from the points where we have not plotted. So, I have drawn a slope here. See, on the x-axis, it cuts at 0.7 and 0.63. So, it is 0. Okay, and in the y-axis, you could see 614. So on the y-axis, it is cutting at 6 and 14. So we all know the slope is nothing but it is dy by dx. So the forward resistance Rf is calculated as delta Vf by delta If. On the x-axis, the difference or the slope is, the x-intercepts are at 0.07, and in the y-axis, the delta If is 8. Since it is in milliampere, so I have wrote it as 8 into 10 power minus 3. See, I have already explained at the x-axis. See, you could see at the x-axis, the difference, the slope intercepts are at 0.7 and 0.63. So, it is 0.07 divided by, and we have y-intercepts are at 14 minus 6. So, it is 8 milliamps. So, it is 8 into 10 power minus 3. When you divide 0.07 divided by 8, you will get 0.00875. The 10 power minus 3, when it goes to the numerator, it becomes 10 power 3. So, when you multiply this number by 1000, we get 8.75 ohm. So, the forward resistance of a PN junction diode is 8.75 ohm. Now, let us draw reverse characteristics of a PN junction diode. Here, we are going to make use of third quadrant. In the same graph, we have to do. So, along minus x-axis and minus y-axis, we need to take. So, along the minus x-axis, we need to plot a reverse bias voltage VR, and along minus y-axis, we need to take reverse bias current IR, and then we need to take appropriate scale for this. See, in the next graph, we could see the reverse bias voltage VR is is in volts, and along the y-axis it is reverse bias current in microamperes. The appropriate scale for our set of reading is on the x-axis. 1 centimeter is 1 volt. Since we have increased the reverse bias voltage in steps of 1 volt, so it is 1 centimeter is 1 volt. On the y-axis, we have taken 50 microamperes. So, we have plotted along the minus x-axis as 1, 2, 3, 4, 5, 6, 7, 8, and along the minus y-axis, it is 50, 100, 150, 200, 250 microamperes. So, we have the readings for the reverse bias characteristics. For 1 volt, it is 0.5. You could see 1 centimeter is 50 microamperes. So, each line will correspond to 5 microamperes. So, at 1 volt you could see I have plotted at 5 microamperes, and for the 2 it is also 5 microampere. For 3 volts it is 5 microamperes. For till 4 volts it's 5 microamperes. At 5 volts the current shoots to 200 microamperes. After that the current increases abruptly. This 5 volt we call it as an breakdown voltage, where the current will flow heavily. So in the next step, from 0 let us connect all these points. When you connect all these points you will get a curve like this. So this part of this graph represents reverse bias characteristics of a PN junction diode. So after drawing all both the curves, our graph will look like this. For this experiment, plotting the graph is very important. The maximum mark is given for plotting the graph. So finally we can write our results as the VI characteristics of a PN junction diode has been drawn, that is for both forward and reverse characteristics, and we have found the new voltage to be 0.6 volt and the forward resistance RF is 8.75 ohm for the junction diode we have used.